Hello and welcome to the second lecture on future punk. So today we want to do a bit more punkish things, or prepare for that at least. Let's just take all the worn clothes of futurism and cut it in pieces and reassemble them anew. And to do that, I want to start introducing a lot of different tools that over the last 100 years or so have been of widespread use, in particular in the economy, to do futurism, strategic thinking, and whatnot. In particular, of course, the field where that is, or the industry where that is kind of the most hysterical, which is the startup and tech industry. So, in the end, I want you to come up with your own startup ideas. I mean, of course, since we are in the arts department, come up with interesting ideas for a startup that might be challenging and worthwhile doing here. But I mean, maybe you have a good idea and raise money and whatnot. That will be a second lecture where I want to talk a bit more about the financing of startups, but also about the design process. So for now, we want to focus on the main drivers. So how do we see that something happens? And of course, here's the caveat. Be careful, just because you think something is boring doesn't mean it is. Also, I think it is important to see the kind of the power of an idea, as this one of my famous or most beloved quotes here is that as long as they think that tech would save the world, it doesn't matter if it actually does. So if you have ever watched the very funny comedy series Silicon Valley, you know that the non-going joke in every episode is that someone says, and make the world a better place. So you should think of your own startup as some kind of inspired tech vision, and end your presentation with that sentence to stay in the good old Silicon Valley tradition. So first, I want to talk about one of the most popular kind of tools in emerging technologies and making really important presentation in companies, not so much in startups, I think, but in big corporations, which is the so-called hype cycle. So the hype cycle tells you that the startup or technology might have a very rising level of expectations. People think that's really great, and then they are totally disappointed, and in the end it might turn out not so bad after all. If you think of, for example, Bitcoin for a long time no one cared, and then suddenly everyone did, and it was like $12,000 or even $19,000 per Bitcoin, and then it collapsed, and everyone says, "Oh, that is so boring, all the blockchain. No one, I knew it before. No one, it's not usable and whatever." And now look, finally we have, I don't know, like $30,000, $40,000 per Bitcoin, or even more. And I think that might even go on for a while before maybe it collapses the next time. So why do we see this? There's an interesting dynamics here that we can study from the perspective of economics and psychology. So if you think of being an economic analyst or someone with market knowledge, usually people that have a knowledge about the market are very good in seeing the market potential of new things. Like, for example, you have a technology, maybe like the blockchain, or maybe like smartphones or so, and you think, yeah, what could be kind of a good scenario in the end of technology adoption if the technology actually finds its user. And usually you come up with two different scenarios. One is kind of the more realistic, that has a very kind of slow slope, and then the best case scenario that it immediately explodes. That's the best case scenario. That's the economic growth. And then look, how does the market actually perform? There is in every market, as we shall see with data a bit later, this S-curve of growth. So new technology, but most things that you introduce from a market kind of point of view start slowly. That has many real-world causes. For example, your technology needs infrastructure. Think of the smartphone, for example. The smartphone built on the already existing infrastructure of mobile phones that in particular in the US, but also in Europe, but also in wide parts of Asia and Africa, had been established during the 1990s and early 2000s. What was missing, though, was internet connectivity, and that started rather late, so with mobile broadband protocols. And these mobile broadband protocols are quite expensive, so the phone companies had to invest a lot of money into their infrastructure, into the mobile base stations. They had literally to put new antennas and a lot of new equipment in. So equipping whole countries worth of mobile base stations for mobile broadband is, I mean, multi-billion dollar investment. And you don't do that overnight, of course, even if you are a phone company. And also, I mean, there is just the physical restrictions that you need people literally going to the mobile base stations that are scattered all around your city, usually high up on the roofs or on big masts, and go there and screw the new things in. So that takes time, and you don't have an infinite amount of experts who can do that, of craftspeople who actually climb up the masts and do the work. So this is why new adoptions of a technology, even if people really like it, usually take a lot of time until it's really available on a broader scale. That has also to do with scaling a company. If you think, for example, Uber, a very much hated company, started in the Bay Area. So San Francisco is one of the cities, I think, with the worst taxi service. I mean, at least in the cities that I know, probably there are worse. So if you want to hail a ride in San Francisco, that's really a very unpleasant experience. And then came Uber and said, well, we can change that. We just have this our platform that connects chauffeurs with customers, and we just take a share. But again, you can't start that in every city alike. You need to convince drivers first, and then you have to have a payment system. The payment system has to scale, so you need to rent servers like on Amazon Web Services also. That costs a lot of money, and you might not have enough money in the beginning. So you start with one city, like for example San Francisco, or one area like the Bay Area. Ideally, that is a dense urban area where there is a lot of people who want to use your new technology. But that's it for the first year or so. Same, by the way, with Airbnb. And even if people in other cities like Moscow or Beijing or so think, oh, that's a great idea, it might take a while until someone in their city comes to the same idea, or Uber just goes there, or Airbnb. So this is why we have slow adoption in the first year or years. But then at one point, the technology is already there. I mean, think of all the railroads that were built in the 19th century. That was a huge effort. All the bridges that had been built, all the railroad stations, and all the investment in the machinery and in educating engineers and the drivers and all the infrastructure that you have built to run a railroad. But once it's there, you can suddenly do a lot of things with that. You can haul a lot of people back and forth. And so this is what happens then. Suddenly everyone can use it and everyone does. So this is when the S-curves gets the so-called hockey stick. It really goes up in a huge growth. And then in the end, I mean, there is only so many villages you can connect with a railroad, and there is only so many people who can buy a smartphone, and if everyone has one, you won't sell more. I mean, at least not every year. And then the curve flattens. That's called saturation. And that you understand the idea of a hype, I put my two arrows here behind the S-curve, and you see what happens. So at first, there is just a new idea and people are very enthusiastic about it and think, well, maybe it really starts very, very quickly. And then over time they realize, we were too optimistic and your expectations lie constantly above the actual curve of adoption. So you are always disappointed. And then you start thinking, maybe my worst case scenario was right. And start adjusting your curve from the best case to the worst case scenario. And then when the adoption really happens, you are completely unprepared because you didn't expect the exponential growth that is in between. And what you see here, and we will come to that in a bit more detail in a second, is the problem that almost everybody has psychologically in accepting exponential growth, or growth which is usually exponential. That's kind of the definition of growth. So that something grows means that the growth builds and builds and builds and builds. And people always think in linear curves. So this is the first tool that I want to hand over to you, that is thinking exponentially. I think this is a really important skill to learn, and maybe you can come up with ideas to hack that apart. Yeah, and then in the end, this is the kind of psychological process. If you see the person first very enthusiastic and then being constantly disappointed and then grossly underestimating the potential, falling deep into the so-called trough of disappointment. And that's how the strategic consultancy company Gartner builds their hype cycle and publishes that every year. So let's see just a few years what they have in their box. So this is last year's cycle, this 2020's cycle, and you see where they see different technologies. So some are really esoteric and I don't know really what they mean, like authenticated provenance. I can somehow imagine what that means, something blockchain-y that keeps track of where something comes from, but I'm not entirely sure. DNA computing and storage. I mean, that was definitely a thing when that was published a few years back by Yaniv Ehrlich, a scientist at that time at Columbia in New York. I was really impressed and thought, wow, that's interesting. So you can have DNA storing information. I mean, that is almost infinite amounts of information and it's totally cheap. And maybe you can grow bacteria or yeast or whatever that keeps your information storage, and so it never gets lost because it's suddenly in the wild, in the biological, in the circle of life. And then I learned, well, it's actually very hard. I mean, also talking to Yaniv, he doesn't believe in the technology as short-term win. That is really a long way to go there. I mean, we don't have any tools to do that in an efficient way. It will cost a lot of money. It takes forever. And this is why Gartner, I mean, I think rightfully says that to become really a mature technology, that is a long haul. It's 10 years or longer, which you see is the small triangle. Then a health passport. Well, yeah, I don't know if that is such an innovative emerging technology. I think things like that exist already, but I mean, people probably in the pandemic became rather in favor of that. So the idea of the digital twin, for example, that we see quite on the rise, I mean, that is an interesting one. The digital twin was much discussed over the last 5 or so years for technology. So if you have big data, you kind of think of, you have your physical world. For example, think of yourself as a railroad company operator. So you have your railroad cars, and you put all the data of every railroad car into your data repository and your data computing logic. So whenever you need to know anything about the railroad car, you have the data that travels with it, so to say, virtually. And that's called the digital twin. Most companies are really far from having that. So most things in the world don't have digital twins. There's a few things that are pretty well mapped. For example, shipping containers. Shipping containers usually have a very good tracking system, and you can always know where they are. They are, however, not very good in knowing what is inside them. So even, for example, when I shipped my things to the UAE, I could always exactly see where things are. I don't have any data on well, the humidity, the heat. I don't know actually if everything was properly packed, if things break. I don't know the vibrations and shaking of the container and all the things that companies actually need to know. So the digital twin would have that, and I did years back when I was still working in my own company. I did a lot of consulting with companies to develop strategies to do that. For example, using blockchain to hand over this information from one step of logistics to the next. So I think this is interesting to have the digital twin. I doubt, however, that we will see that soon for people. The digital twin for people, I mean, you could think of that as your social media profile. Your social media profile has a lot of information about you. It's almost like what you need to know for yourself. Some years ago, I had this idea of the algorithmic me that is about the same, so that you have kind of a representative of yourself in data that would do things on your behalf. Like, I mean, why do I need to look, for example, I always buy the same running shoes like every year or two. So why don't I have a digital agent doing that on my behalf, looking where these running shoes are on sale at the moment? Or so why do I have to do that on my own as a person? So I think there is some potential. The question is just who is paying for it. So I'm not sure of that. And then, of course, are the things that no one likes anymore, like bring your own identity. I have no idea what that is actually. Or carbon-based transistors. Yeah, maybe that is a disappointment. And nothing seems to enter the plateau of productivity, the things that actually work. Well, let's see what the Gartner said in 2019. Let's look what we have here. And now comes the surprise. Is there at least one technology that you saw 2020 already in 2019? You would think that things start with the innovation trigger and then go up and down the curve, but actually I don't see anything. Well, I mean, we could do now the same game and just pretend we hadn't seen 2020 and look at 2019 and look, well, there is 5G at the totally hype and it will fall down. I think that was very well observed. I mean, 5G is okay, but I mean, it will not solve the world's problems. And then, yeah, low Earth orbit satellite systems. I somehow missed that was such a hype, but maybe it was. I mean, I don't know everything. Synthetic data. That's an interesting one. I mean, you see many of these terms are very phony. I really like them. Nanoscale 3D printing. I First of all, I don't think that that will take more than 10 years because we have a lot of that already. And that gets a huge push at the moment. And there is a lot of investment in it in combination with artificial intelligence. Google Fold or AlphaFold, the artificial intelligence project brought forward by Google in their AI team, that predicts the protein folding of molecules. So I think this is too conservative here, but I mean, who am I to know these things and so on. So you see, and then let's go back. Let's see what we have in 2018. There's mixed reality and augmented reality really on the rapid decline. I think that's true. No one is so much interested in that anymore. The connected home, I totally agree. Blockchain, I think that was too conservative. Blockchain in 2018 was in the trough. They had their deep point in 2018 because in 2019 most people didn't see that, but it started to rise again. So I think that Gartner is too conservative here, and other things like smart dust. I mean, I remember first reading about smart dust, I think in the early 90s in the Scientific American. And a few years later, I totally remember reading in Wired magazine that smart dust is actually have developed for the use in the military. So smart dust is little chips like RFID chips or so that you can basically, they're so cheap that you can throw them around like dust. So I don't think that that is such a new idea here that it has to be here on the innovation trigger. I would rather say smart dust is so esoteric that it goes kind of flat, but it doesn't mean that there is no market for it. So yeah, back in 2017, so 5G on the rise. Well, that is true. I mean, at that time, the former US President Trump had discovered 5G and said, well, who needs 5G? We have 6G and that is much better. Of course, there is no 6G and at least yet. And so that was kind of a hoax, but definitely people discovered 5G as a potential. In a way, these trends that are made by super huge corporations like big semiconductor manufacturers and phone companies, it's a bit unfair to put them here because it's easy to see the hype cycle. I mean, if a company like Huawei and others invest billions into a technology, I mean, it's easy to predict that this technology will come at one point. It's very rarely the case that companies like that mess things totally up. So now let's go back a bit further. Yeah, virtual reality, augmented reality, again on the trough of disappointment, so that moves not much. So probably it is a disappointment and stays there. I mean, natural language question answering, I think is a kind of polite term for chatbots. And I think in 2016, everyone using any kind of help service was already annoyed of that. Yeah, here's quantum computing, and I think they say more than 10 years. I think that is true. The question is if quantum computing will actually become such a hype, because I mean, again, it's kind of this industry invests billions and billions into it, and it comes slowly, step by step. And of course, we don't know if it will ever fully work, but there is very convincing first steps. So that might actually not run through the hype cycle. It might just continuously grow. Yeah, let's go back a bit further in time. So you see 2010, so 10 years ago. And that's totally interesting because there's things I've never heard, or I can't remember at least. Like, for example, the human augmentation. I mean, yeah, I think that, I mean, thinking of cyborgs also, that is certainly a thing. I'm very fond of that. I don't know if you really have to put that here. Microblogging, which is another word for Twitter was definitely on the fall at that time already. Um, and I think that here they have something right, like for example the pen-centric PC um, um, that would come, which is the iPad Pro. However, the iPad Pro was not brought to market for another 5 years. So they were a bit early in predicting that. And if you go even further down here, 2005, yeah, so quantum computing is already there. It has not moved much since then. Um, I mean, biometric user identification, come on. I mean, that is so ubiquitous. That is certainly, that never went to the trough. That just became a thing. Um, yeah, so you see, there's a lot of inspiration for you. Just go through these technologies and enjoy them all. For further inspiration, I've over the last month or so started to put together what I saw on Twitter. There was some conversations that were really interesting of people in the VC field, in the venture capital field, asking their followers what they think of industries to come. And I've put that together for you in this spreadsheet that the link you find in the syllabus. Um, and group these things in different industries. So, for example, if you think of automation, so we have driverless transportation in particular. Of course, that means driverless lorries and trucks. Then home robots or whatever. I think it's really fun to discuss these all in person. Then we have a lot of building and construction that's going on, like modular housing and additive construction. There has been quite some advances of 3D printed houses. I don't know how much sense that actually makes, but it's a thing. I mean, people are doing that. And then, of course, I mean, if you look around, I mean, just look what the UAE does, terraforming and building artificial islands like the Palm in Dubai or Lulu Island in front of downtown Abu Dhabi on the Corniche. And then interesting material like nanotechnology and graphene. And then all kind of other things like peer-to-peer systems, which I think have a great potential, and we will certainly look into that for coming up of interesting things. I mean, thinking of blockchain in particular, maybe I have a bias because I've worked in that field for quite a while. So blockchain offers a lot of potential to dream, I would say, and to make punkish things because it's rather anarchistic. But then there's other things like the prediction markets or distributed autonomous organizations that have been realized already with blockchain systems. The idea of changing finance to have a nano venture capitalist, there is a lot of things going on here, although regulation of the financial markets is a bit kind of counter this. And then in the end, identity management, that is a field where a lot is going on. The idea that you have your identity under your own control and don't hand it over to companies like Google or Twitter or Facebook to have a profile of yours. And then the mental health thing. I mean, this is really interesting after the wave of legalization in soft drugs like marijuana. The next is psychedelics. I mean, in the UK, clinical experiments with psychedelics like LSD have started. We should definitely discuss that for thinking future worlds. And so on. So there is a lot of things to play with. Let's go back to our presentation now. So one thing that's important to keep in mind for all the markets and dynamics in the world is what is growth. So, as mentioned in the beginning, in explaining the hype cycle, humans have, I would say, a very weak ability to really see growth, which is really interesting because it's so ubiquitous. But our brain is basically seeing things linear. That means today I have 5 euros or dollars. Tomorrow I have 6. Day after tomorrow I have 7, 8. Also, this is linear growth. I get one at a time. This is how wages function. So I get the same salary every month. There's no growth in it. I mean, I may get a raise once in a while, but that's all. And of course, if you think of wealth generation, that's usually not how it works. So you start a company and you want the company to grow. And with the company growing, I mean, of course, the value that the company has usually grows. And so let's look what growth means. So we have a function of some value at the beginning, and the function in the future, like one period later, is the original value times some factor. For example, today I have $10 and tomorrow I have 11, then this factor is 1.1 or 10% growth. And then comes the interesting thing. For the future, every time I go a step further, the factor gets multiplied with what I had already. So I have 11 euros today, I might have 12 tomorrow, I might have 15 the day after tomorrow. And that is exponential growth. It's called exponential because the thing that makes it growth, the time, is in the exponent. Yeah, so let's look at exponential growth briefly on a spreadsheet. I've prepared that in Excel. Yeah, good old accounting practices. So exponential growth, of course, can't start with 0. I mean, if I don't have money, nothing can grow. That's different for linear growth. Linear growth would add money every day, but grow linearly. Exponential growth is a function of what I already have. So I need to start with, for example, $1, and the factor R with 2 means that it doubles every time period. Can also, of course, be the number of people infected with COVID. Then the doubling means, I mean, that is the time. Like, for example, the number of infected people doubles every 15 days or so, which I think is a realistic, or 20 days. Then from 0 to 1 to 2 is always this time period. So that's called the half-life because it comes from the logic of radioactive decay, the time that it takes for half the atoms in my, or half the matter in my sample to have decayed. So let's just start with 1, and then it doubles ever so often, and you see after, so it seems literally nothing to happen in the beginning, and then suddenly it goes away. And that's exactly what I tried to make clear in this fallacy that leads to the hype cycle, the psychological fallacy. This is underestimating the growth. At first, people think linear, that would kind of go like that, but that's not how it is. It kind of stays very flat, and then suddenly comes what people in business often call the hockey stick. Since I don't play hockey, I just take that term. It's one of these techie terms that tech people always use. And the interesting thing is that actually it doesn't matter so much how large either of these quantities is. In the end, it grows incredibly fast. I mean, even if we have a very low starting point and a very small r. So since that is very hard to see anything here because it almost goes up vertically, I hope that is the right button here. Yes. So we change the axis to logarithmic scale. Logarithmic scale means that we go up in powers of 10. So we start with 1, then comes 10, then 100, then 1,000, then 10,000 or so. I mean, you know that, of course. So this is the way growth is usually depicted. So instead of having 1, 2, 3, 4, 5, you have 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 5, and so on. And you see the curve is now a straight line. So let's change R to, for example, 1.1, and you see it is still a line. So this is how you detect exponential growth, that in a logarithmic scale it is close to a line. And by the way, I mean, just what I said, the 1.1 of course grows much slower, but in the end it will also go through the roof. It just takes a bit longer. So let's go back to our presentation. In tech, there is a lot of exponential growth that people realize that happens, in particular in a field that became emerging after Second World War, and that is electronics. So you might have heard of Moore's Law. It's named after the founder of Intel. Intel is one of the leading semiconductor manufacturers in the world. It has become under quite some pressure since other companies kind of overtook Intel's capacity, and so we have a lot of other companies now that kind of produce better semiconductors, or higher capable semiconductors than Intel does. But I would say the final verdict here is not spoken. So, and more about 55 years back, noticed that the capability of calculation power, which he said the integration that takes place in integrated circuits doubles about every 18 months. So there is no natural law behind that. So what Moore was formulating here is, so he saw that the money earned with semiconductors and could be invested in better equipment and research and development, and also the physical processes to push your semiconductor production further, doubles about every 18 months. So it's there is no natural law behind that. It is just an observation and also some kind of business strategy. And that is definitely true. I mean, there's a ton of examples that you see how that plays out. For example, here you see the capability of all kinds of computers. So while you have these huge mainframe computers in the 50s and 60s, then starting in the late 80s come the personal computers that actually catch up pretty quickly. And so the supercomputer power starts, and with kind of a time lag behind that follow the personal computers. There's another side to that. Computation becomes very cheap. So this is another way of looking at Moore's law, is that getting your computation is also exponentially dropping in price. And so while when I did my thesis in the early 1990s on machine learning and AI, actually you couldn't do much of machine learning at that time. I mean, it was fun to do that, but any kind of real-world application was quite outside of what computers actually could perform. And it's not only the computation power. It is another thing that for the field of machine learning is even more important, which is memory capacity and storage capacity. So the memory capacity is how much computation memory a computer has, and a lot of AI model building runs in memory. So that means that your whole model has to be loaded into the computer's RAM, into the computer's working memory. And of course, it would be bad if that would not grow as fast. There's a funny thing with the memory capacity. Although it used to grow by 18 months, double by 18 months, like the CPU capacity in calculating power, that seems to slow down significantly. I mean, because it is quite there is quite some physical constraints in which classic magnetic storage at least runs here. Then we have another law here, the mobile connectivity. So how many people are mobilely connected? We will look into that into more detail. Then we have the data rate that people have at home and the internet bandwidth. So these are all exponentially growing growing factors. And I mean, again, I mean, just look at that, the computation efficiency. I mean, the energy that it takes to do 1 million calculations per second, I mean, is infinitely small compared to the time when I was born. The storage capacity shown here in gigabyte available. I mean, you know that we have reached long exabytes of storage capacity in the world. This is in particular important for big data, because the machine learning models need a lot of data to be trained on. And again, when I did my thesis, I just didn't have enough data because there was not enough storage to do that. For example, there was not many books available that would be electronically stored, so you couldn't do training for natural language processing. It's interesting to use that now for prediction and coming up with ideas and planning ahead. So Paul Saffo, who is one of the leading strategists in futurism, he is one of these people who everyone looks up to. So he has formulated, I would say, this very interesting law. So if you want to look ahead, look double the time back. And that has to do with this exponential growth. So if you think of how much change was possible in the last 10 years, you can expect that that is about the amount of change that you can expect in the next 5 years. So if you think back 10 years, 2010, so that is before the Arab Spring, for example. The iPhone is already there, but the iPad is not. I mean, at least the iPad Pro is not. Just make a list of things that you see that came up in the last 10 years that brought significant change to the world or to technology, and then think of what similar change could come up in the next 5 years. So I have a few heuristics now for you to come up with startup ideas that I just took from other people. You know, FuturePunk. That means I look what people came up with and take it, that we can repurpose it. So let's start with Akival Garg. So he used to be a manager at Facebook, I think the product lead or something like that, and then of course became wealthy when Facebook was very successful, and now he is a startup guy, and he has kind of this list of why now. So why would you come up with your startup idea now? And this is what he says. So there is these 5 buckets of answers. So new technology allows products that were not possible before. I mean, that is just how things are. Think of like, for example, nanotechnology. I mean, with nanotechnology, you can do a lot of things that were totally impossible before in terms of material. And we see a lot of nanotechnology now in textiles, in surfaces also. I mean, there is you just need to stay ahead of the curve. You just need to know what new technology is there. Other examples of new technology, of course, is CRISPR, for example, editing the genome. I mean, the idea with DNA storage is directly linked to the invention of this tool by which you can actually edit the genome. So that is a good first one, and that is definitely the driver of a lot of startups. Then, of course, there is new regulations. For example, in the late 1980s, in most European countries, the telecommunication market was deregulated. So before that, telecommunication in most European countries was state-owned, and monopoly by the state was held. And that was deregulated. So suddenly you could do things that before would have been a nice idea, but would just not have worked. For example, you could come up with things like a fax machine. A fax machine, over many years, for example, German Telecom would just not allow. So either you would use it illegally, but then, I mean, to whom would you send a fax if no one else has one? Except people who in clandestine ways have that hidden. But that is, of course, not how communication works. So you need regulation to change often for your startup actually to work. New business models emerge. I think this is also important to see that, for example, something like delivery services. Delivery services require a lot of business models that have to be there beforehand. Like, for example, payment. You need some kind of internet payment provider that you can trust and that your customers trust as well. Or peer-to-peer business models emerge. Like, for example, someone comes up with Airbnb, and so you see, oh, that's actually a great idea. So let's think of where else I could use that. Maybe Airbnb for office space, or maybe a ride-sharing service also. And this is exactly how you come up with new ideas. You look of new business models that other people came up with, in particular after regulation changes. That's an interesting one. It's often underestimated, but I mean, in the moment, you could book advertising on Google. You could advertise for totally niche products. I mean, products you could never market before. I mean, think of yourself as being a highly specialized company. How would you ever find your customers? So this is a really interesting one to have a close look. In particular, if you come from highly regulated markets, like many markets here in the Middle East or in Africa and South Asia as well, are very, very regulated in terms of advertising. But that changes quickly. And if you see an opportunity here, like for example Zomato did in India, things change and someone has kind of the courage and the capital also to start a new company, then you might actually be quite successful. And that's a tricky one, that is customer behaviors change, because that is usually something that you see more easily after the fact. Everything is obvious once it is. But it's very hard to know that beforehand. So this is the slide that Garg made for that, and the interesting startups are those who facilitate this change. And you could really see that, for example, with Twitter, Facebook, and Instagram, in particular, I would say with Instagram, that really changed how people use their phones. So with Twitter, people started to post pictures, but at first Twitter didn't support that, so you needed other services like, for example, TwitPic or whatever they were called, because you could only post links. Twitter was text only, and then very late in the game, Twitter included pictures, but there was already Instagram, and Instagram does that very seamlessly. It runs on your phone, you just take the picture and post it. I mean, you all know that. And so before Instagram, it was not easy to share pictures like it is now, and so people changed their behavior. They changed how they use their phones, they changed the pictures they take, the selfie comes with it, and so on. So you could say that Instagram is one of the companies that definitely changed user behavior. Another kind of leader in the startup field is Paul Graham. So Paul Graham is a tech guy, but I think the interesting thing about is that in 2005, with others, he co-founded the Y Combinator. So Y Combinator is kind of the first great angel investment fund, and so angel investment, we will talk about how to finance startups in the next lecture a bit. So angel investment is what you need to get things to a shape that you can actually go to a real investor. This is why it's called angel. I mean, that's people who kind of give you the money despite you don't have anything yet, or other than your idea, basically. And Y Combinator is a super interesting place. I mean, really look that up and definitely look at their site, Hacker News, which always has the latest trends in tech and beyond. I mean, just examples that startups that Y Combinator, I mean, literally incubated, literally started is Airbnb, Dropbox, Reddit, and many others. So the first thing is how to have a good startup idea. I mean, the best is you have a problem. Because the problem tells you that there is something missing, there is something to be solved. And it's called solutionism, but often that helps. I mean, if you have a problem, come up with a solution. I mean, so if there is no problem, better don't solve it. That's a bit esoteric idea here, dig the deep well. So what does that mean? So Paul Graham describes, you could think of the horizontal dimension of the world as how many people will use your startup. And the vertical line, the deeper you go on the vertical line, the more people need your startup. So, and then there is startups that are kind of the super successful startups, like Google, because they have something that people really urgently need, many people, but also many people need it. So it's kind of a big, you could think of a big hole in that world. Many startups, however, focus on something that is only incrementally better than what is all there already. So people don't need it that much. It's just nice to have, but really many people can use it. And that's usually not so successful. I mean, first of all, I mean, why would people change their habit? And second of all, I mean, if it addresses many people, that means you don't get it started easily because you can't address these many people. And how likely is it that someone is not so urgently in need that they actually recommend it to someone else? So the great startups, says Paul Graham, and I tend to agree to that, start with something that is kind of a niche, but for the people in that niche, it is kind of salvation. I mean, it really solves a big problem for them or does something that they thought was never possible. And then these people spread the word, and suddenly you can concentrate and broadening that up. It's always good if the thing works for yourself. I mean, so coming up with startup ideas, a good way is just think of what is it that you would really like and you would really be willing to pay money for, but it doesn't exist yet. So if you, whenever you have in your head the sentence to say, if only someone came up with that, I would really pay them money, then probably it's a good idea to do that. Of course, it also helps if you notice things like that in others. So you can ask other people exactly the same question. And also, of course, I mean, look around and try to see what's happening. And that is an interesting one, that you go to school for the future. So what Program actually says is, I mean, it's no wonder that so many startups are founded by college dropouts. However, not everyone. Not every startup founder is a dropout. Many are also by postgraduates or so. So, however, he says that when you go to college or university, I mean, that's such a luxury, that's such a privilege. Don't concentrate on the wrong things. Don't learn another programming language, because when you are out of college, this programming language is already long outdated and deprecated. And I think that is very true. Look at the speed in which, for example, JavaScript changes. It's almost not worthwhile learning JavaScript unless you really need it now. I mean, if you think of the version 6 now and compare that, it's almost that you can't recognize it anymore. So I think there's a lot of movement in programming languages, and if you have learned one, I mean, probably you learn another one very easily. So this is what he says: don't concentrate on skills. Do things in university that really broaden your mind. So to quote him verbatim is, what you should do is spending your time in college in ratcheting yourself into the future. So how do you do that? I mean, he says, well, do things that kind of cross across boundaries. So if you are interested in computer science, do things in the humanities as well, or do things in other fields as well, because only then you get the broader picture. And this is something that will be very hard to maintain once you leave university and enter the business world. And then finally, that's an old one, competition. There's the old saying, if there's no competition, then there's probably no market. And that's the point. I mean, how likely is it that you have an idea that no one else has before? I mean, of course, that can happen, but actually, it's not so bad if other people had the same idea. I mean, actually, it shows you that there might be a market. It might just be that other people did it wrong, or that there is still space for a second to try. And if you worry that you are late in the game, that might actually be not so bad. That might actually show you that there is a game in the first place. Let's elaborate a bit on these ideas. So the first thing that you should concentrate on, as said, I mean, is there a problem, or do you need it yourself? Is so. I mean, you start with the things that you need yourself. As mentioned, I mean, if you would pay money for it, then probably other people would too. You ask other people what they are missing to learn about things that you might overlook, and whenever you feel that you would pay for what someone else did, it's probably the right thing to do it yourself. And so, however, for a startup, I mean, that means you grow over time. Don't look for something that replaces something that's in place now one-on-one. I mean, like, for example, don't come up with a new word processor. I mean, there is so many word processors. I mean, that's not a startup idea. You have to think of what people in like 5 years would need to replace something. And I think this is this really interesting to see the companies that successfully came up with ideas what to do in the cloud. I mean, like, for example, Google Docs. That was a very slow process that led to Google Docs. I mean, it started like, I can't really remember, like in 2005 or so, these collaborative tools where simultaneously people could write on a document, and suddenly you would realize how much better that is to work together with colleagues, where you can edit a document jointly and don't have to send it back and forth as a Word document. And it took, however, I think like 10 or so years before that found a broad adoption. Many people use Word still, but I would say, I mean, if you look around now in universities, Google Docs have found their way. I mean, now they are well established as a way of exchanging text. So, and then comes something that is so important that I want to stress this a bit more, that is look for waves. So waves have to do with time, things change over time. And we shall have a dedicated lesson over that in week 5, when we look at pace layers and the speed of change. So waves are postponed for now. Yeah, this nice quote by Paul Buchheit. So Buchheit is the inventor of Gmail. And also the person who came up with the first basic idea of Google AdSense, which is the money machine of Google, and is also credited with bringing the totally hypocrite claim "don't be evil" into the Google marketing bubble. But I think this is exactly the imperative for building a great startup. This is live in the future and build what's missing. Yeah, this is what you should do. And maybe, I mean, since we are here in the arts, you could think of what is not missing and come up with things that are a bit more creative than just pragmatically looking. We shall look at 2 examples. One is retail, the second is mobile. So retail during the pandemic, of course, has dramatically changed, and you think of online retail now being the major force. However, I took this slide from a presentation before the pandemic in early 2020 by Benedict Evans. So Benedict Evans is an analyst, used to be an analyst at the venture capital firm Andreessen Horowitz in the Bay Area. He is now in London, and it's always good to follow him. He has always interesting things to say, I would say. Often I don't agree, but his data is always good. So I just, in the future punk sense, I just take what he has and repurpose it for my own ends. Yeah, and you see that Amazon clearly has this exponential growth pattern in its revenue. This is, of course, not only retail. I mean, this is the caveat. I mean, of course, Amazon does other things too. For example, Amazon Web Services. However, over the last years, retail, which was always kind of the people always say Amazon doesn't earn money by retail. That has dramatically changed over the years. And you see just in the last 15 years how this growth pattern becomes visible. And I would say since 2015, no one can deny this exponential growth. So it is predating the virus. However, what happened, of course, is that the pandemic completely changed how people purchase things. So the UK is clearly ahead of the curve in terms of adoption of online commerce. The UK and South Korea are always the two leading, so far, the two leading societies in terms of what's going on online and mobile. So you see that basically what he says here, that like the growth of 5 years has been established in just 1 year. And however, the same thing that I said in the last chart, and the growth pattern is very consistent over many, many years. So that would have happened anyway. So it is true that the virus accelerates things, but it didn't make things happen. So you can blame the virus for many things, but it is not the black swan for retail. Retail, the decline of brick and mortar retail and the rise of online retail was long in the making. Another depiction of that, and so you see how the retail in general goes up, also offline, and then you see how the virus hits. A very good source, if you look for data, is the research published by the Federal Reserve, that is the currency bank of the United States. So here is this URL. You find incredibly useful databases on economic development in the United States. And what you see here is, in a way, the complementary chart to the online retail, because online retail, since it is not brick and mortar, has to come to you. So someone has to deliver it, and so what you see here is this rise in employment for delivery services, basically. And you see again very consistent rise year by year, although of course very much accelerated during the pandemic. So if you think of these changes, there's a lot to discuss here. So first of all, the environmental impact. There is, I would say, conflicting studies, but I would say most studies that I've seen, in particular, there is several in the UK, analyzing the carbon footprint of different ways of getting your goods. It seems to be that delivery has a much lower carbon footprint than going to the store yourself. And that makes sense in a way. I mean, if you think of, if you live in a big city and you walk to your grocery, then you might think, well, how much carbon do I create? However, the stores that have shelves and have the goods in the shelves have to keep a lot of stock. While if you have big warehouses from where you distribute, you can optimize how many goods you actually need. And that lowers the demand for excess stock. So this is the first advantage. The second is, in groceries, you have much less waste. The goods in a big warehouse, in a big wholesale logistics warehouse, are properly chilled. So the storage is optimized, and you can much more precisely optimize how much you actually get in, for example, in produce or other delicate groceries, so that nothing gets over their shelf life. While a small store has always to keep like fresh goods, no matter if people actually buy them. And so roughly 50 to 60% of groceries are not sold but thrown out because they turn bad before being sold. So there is quite something to say for online retail and delivery. However, people buy in a totally different pattern. I mean, thinking of walking into a grocery store and seeing the products on the shelves, I mean, this is not how it looks when you go to an online presence of the same grocery store. You have very different search patterns. You are in a very different way addressed. So in the store, you have the so-called secondary positions, the promotions at the head, so-called head gondola. So at the head of the shelves, there's usually a stack of promoted goods that have a special price. How would you do that in online? I mean, you have to kind of have these goods advertised for on the screen, but many people go mobile, so there's not much space. So this kind of promotion doesn't work as well. So you have to be much more creative in getting people's attentions. The same is for new product launches. I mean, in a store, you have special promotions for new products. There's a big stack, stack of the new product and a cardboard saying here is something new, try it out. It's at a special price. But online, people are not looking for that, so it wouldn't show up for them. So this is really something to be considered. I mean, if you think of the ideas that I pointed out earlier to come up with a startup, so here you have the, so to say, opportunity that is completely different ways of addressing your audience, of making people aware of your goods and promotions. This I found very funny in Benedict Evans' presentation. It's about, I mean, even if you think you have a good retail idea, that doesn't mean that it actually works. Like 20 years ago, 20 years ago, people started to sell mattresses. I mean, mattresses is really the thing. It's a total pain if you buy that in a store. I mean, you have to have a really big car to get it home, or someone has then to get it home for you. So it seems like a good idea, and so the US startup Casper started shipping mattresses, and in no time other mattress retailers thought, oh, that's actually great. And we have our logistics already here, because we have to ship the mattresses, we have to drive that to people's homes anyway. So why not do the same, but just cheaper? And so now we have like hundreds and hundreds of mattress online retail shops. This is what's called having a moat. You know, a moat in medieval Europe, or probably other parts of the world also, is this dip of water around your castle that makes it very difficult for attackers to reach even your walls. And in startup language, a moat is what you have early on when your startup is still vulnerable to competition, in particular to competition from big established companies that just throw money in to defend your market. So that's called a moat. And the moat for Amazon over a long time was that they were just better in having a catalog with the books. And then they just offered to ship the books for free, while everyone else would have shipment costs on it. So just thinking of how they grew. And they were very early on, like in 1994, Amazon was founded. And they only did books in the beginning. So it was a very concentrated, very niche market, and they were very good at that. And so none of the other retailers really cared. Although at that point it certainly would have been possible. With the mattresses, it's totally different. Since bookstores didn't have logistics, no bookstore knew how to ship books to people's homes, but mattress stores do know that. They have already the need of shipping the mattresses. So this is not a moat, and this is why it's easy to copy. So there was the first example, retail. The second example with exponential growth will be mobile, where you see a horrible typo that I just noticed. Please excuse that. So here, oh, that was one too fast. Here you see the the mobile subscribers worldwide, so the dotted line is the actual number and the initial prediction of the International Telecommunication Union, which is the United Nations transnational body of organizing frequencies and everything that is connected to communication, basically. So you see the typical hockey stick curve. So clearly, mobile in the late 1990s, so around 2000, took off. Until then, the growth was very slow, and then it exploded. And that had, I mean, literally to do with putting up mobile base stations everywhere, in particular outside the US and Europe. And if you look at these slides, you see that the adoption curve, these S-curves, are the same everywhere. It's just shifted in time when the different regions adopt mobile, and you see in the logarithmic scale that it is indeed truly exponential growth that we see all over the world. And here the mobile data traffic, I mean, no matter where you look, South Asia or Sub-Sahara Africa, it goes up and finally connects everyone. And that is the fascinating thing, that basically every household in the world has now access to mobile communication. Yeah, so with that we have touched the final aspect of economic growth, which is what I call the global momentum. This is, so if you think of what is special of our time, so there is, I think, two things that are really different from any other time before. The one is the number of people living on Earth, which just changes how things work. Because if you have, I don't know, 100 million people, the size of a country, I don't know, like Germany or Pakistan or whatever, or Nigeria, and that's the whole population of the world. People are very distributed in different places. Things that work are different. They are much more local. But with 8 billion people around the globe or more, and huge population density centers in Europe, in South Asia, in Southeast Asia, in Africa, and of course in the Americas. So in every continent we have these mega cities, these huge hubs of densities that are very well interconnected. That really changes, and the business model like Facebook's or many other internet-based business model would never work unless there would be billions of people potentially using it. And that is something new. And I mean, this slide, I mean, clearly shows you, I mean, how extraordinary the population growth has been in the 20th century. I mean, the number of broadband mobile contracts active today is larger than the number of people who lived when I was born. I mean, just think of that. When I was born, there was about 4 billion people, and now we have 8. So in my lifetime, the population in the world has doubled, and that, of course, means that nothing is the same. And if you look at the logarithmic scale, this unbelievable growth of the 20th century becomes particularly dramatic, because you see that the world's population was exponentially growing basically since the Ice Age, and then suddenly that totally changed. And there's many reasons for that, which we might discuss more in detail in the coming weeks. At the same time, the so-called fertility rate, that means how many people how many children do people have, dramatically goes down. And it is the same everywhere. So, I mean, of course, there was very dramatic changes like the Chinese one-child policy. But if you look at that, it's actually the same everywhere in the world. It really goes down dramatically, and you can see that. I mean, in the long run, it's not hard to predict that that will converge and probably lead to a stable population. However, there is a huge momentum. I mean, a lot of people are, so to say, born now who don't have children yet, and even if they have only a couple of children, that means that the population will still grow. I mean, hopefully, because if it doesn't, that means that there would be probably horrible diseases or other catastrophes decimating the number of people living. So, the United Nations scenario is that there will be probably like 11 billion or 12 billion people in the end living on Earth, and that would be then the stable population and then probably decrease a bit. So this is what we can expect. And of course, we have to think of how this planet will look like. And that's really a fascinating task for this class. Come up with your startup ideas for a startup that deals with this enormous population density. And now comes the second big change. I said the first was that there is so many people. The second is that people are educated. That is in a way complementary to the mobile broadband or to the internet access of people, because I mean having internet doesn't do much if you can't read and write. But you see here in what short time basically everywhere in the world people learned to read and write. And that is, I think, really amazing. And so we can basically say that now most of the world's population has access to knowledge if we assume that the countries they're living in make that possible. So it's more a political problem now than actually a problem of education. That means, of course, only basic education. It doesn't mean that everyone gets their PhD immediately, as you all know. However, I mean, it is a great chance to think of the world being very densely populated and very literate. So I think with that comes then, of course, the next question. This is secondary literacy or so. That will be a huge education task in every country. By the way, I mean the illiterate population in Europe, for example, in Germany, where I come from, is still 5%. So it wouldn't probably go any lower than that. I mean, there is people who suffer from very strong dyslexia, for example, like one of my sons. And for those people, it is much harder to learn to read and write. And if they don't get special education help, they might just end up in not learning it at all. So you shouldn't think of, oh, there is still like 10% or so illiterate people in the world. Well, that's true. However, there is a number that is kind of the baseline, and that is something like 3 to 5%. Yeah, and finally, the mentioned urban density. You see here, and that's also an amazing number, that the average number of people living in the 5 top urban clusters in China is more people than living in Germany, for example. And although, for example, here the greater Tokyo area is only half of what that is, I mean, but think of 44 million people living in an urban area. New York and London, both the greater metropolitan areas, are about 20 million people. That is also the Bay Area, Sao Paulo. So these urban agglomerations also, I mean, of course, offer great opportunities. The carbon footprint of people living in these urban areas is much lower than people living in rural areas, which makes sense because, I mean, usually the distances that you travel in the city is much smaller. People use more public transport, except in the Emirates, but I mean in other places of the world where there exists public transport and people use it. And people living in big houses. So it's much cheaper to heat or chill big houses than single houses. So if people live in high rises, they just use much less energy for the climate in their house, and so on. So there's many reasons why living in a city is actually favorable in terms of environmentalism. There is a backlash, however. Just recently there is this exhibition by the famous architect Rem Koolhaas in the Guggenheim Museum in New York, and Rem Koolhaas make a very strong point for going back to the countryside. It's very kind of backward looking in a way, but it is kind of this reaction, and I want to talk to you about that in a later session, when we again revisit utopian thinking and kind of this idea of back to the nature. In the next video, I want to continue to talk about these business strategies. I mean, you see clearly here what is also exponentially growing is the global creation of companies. It's no wonder. I mean, if there is suddenly so many people, I mean, you would expect that more people start companies. And with that comes a huge push of investments into people's startups, and I want to walk you through that. If we look at the syllabus, what is to come, so we have the speculative strategies and big business today. We go a bit more into the arts after these 2 weeks of the hardcore business tools, and then we will concentrate on speed, on and kind of quasi-religious thinking in the later weeks. So let me just click on this. So this is where we are here, and I have put quite some things in these weeks syllabus. So you have this funny slide that design thinking is in the trough of disillusionments. I think that is probably true. You see Garg's startup ideas here, and then I have here these very nice collections of slide decks that I want you to look through. So here you see the original pitch decks by which these companies got their venture capital funding. So by which they convinced investors to pay them money to start their companies. Here is another one. And so please have a look at that as an inspiration to come up with your own idea for such a pitch deck, because that is the assignment. And otherwise, I mean, you see here the readings about the hype cycle, Paul Sappho's seminal paper on his way of forecasting. I mean, that is really a good read. Quite some nice videos to watch, and the spreadsheet with all these future industries, these weird ideas of future industries. So next week, in the next video, I continue to talk about these speculative strategies, talk a bit more about startup financing, and then go further to techniques like scenario planning and speculative design.